Alright, let's take another look at an aspect of graphing functions. So here we've got this graph, and don't copy this down yet, just go ahead and watch. What I've done is I've graphed this function, negative x squared plus 4x plus 2. And automatically, you guys from our last discussion should realize that we're going to get an upside down or downward opening parabola because it's negative 1x squared. A is a negative number, which automatically lets us know this is the graph we're going to get, which is what we expected. Now, one thing that's nice about these, they're not as easy as linear functions, but there is a predictable pattern that we always get these shapes called parabolas, which are just these basically arches. Now these arches, one of the aspects you probably noticed at this point is that they are symmetrical, meaning that the left-hand side and the right-hand side are identical, which gives us something which we call the line of symmetry. And the line of symmetry, you may have learned this before, is if we were to take this piece of paper off the computer and we were to fold it so that this right-hand side and the left-hand side would match up, the fold would be right down the middle, right here, where the cursor is. And we'll draw this in just a sec. Okay, this is what we call the line of symmetry. And the line of symmetry exists for any parabola, that these parabolas will always be symmetrical, so there's going to be some center that we're going to find here. So for example, this line of symmetry is right here, which is at 2. So what I would do is say my line of symmetry is at x equals 2. Now if I were to change this graph to maybe, let's try this, negative x squared plus 6x minus 2, my parabola moves. It moves. Now it's still downward facing because a is a negative, but then now look where my line of symmetry is. Hopefully you're noticing it's right here at x equals 3. How about one more? What if I change this to x squared plus 2x plus 4? Well, my graph flips upside down because a is now positive, so we get an upwards opening graph. And notice where my axis of symmetry moved to. It's right here. Even though it's upside down as a U shape, there is still an axis of symmetry, which is at x is negative 1. Now, along with that, there's this key number, which, let me go back to the original, x squared, oops, didn't mean to do that. X squared plus negative x squared plus 4x plus 2. That was the original one we were working with. Okay, there we go. Now, along with that line of symmetry, there's a key point which it makes sense. If we're talking about a rocket ship or a ball going in the air, that one of the key points that we would notice is this point right here, the very top of the graph, because this would be a key place where, if it was a rocket, this is where it runs out of fuel and begins its downward trajectory. If it was a ball being thrown in the air, this is where the gravity catches up with it, all the energy is gone from it, and gravity starts pulling it back down. Well, this point has a special name called the vertex, and so finding this vertex is also a key thing. So if you can find your line of symmetry, then the vertex is easy. The vertex is right here. And we call the vertex a maximum or a minimum based on whether the graph is downward facing like this one or upwards facing. So for example, our line of symmetry once again is at 2. The vertex would be right here at 2, 6, and we would call it a maximum vertex because it's the maximum height that this ball or rocket or whatever would reach. Now think about our last example we were just looking at. Let's make this x squared plus 2x plus 4. This opens the other direction. Our line of symmetry, just like before, is at negative 1 when we showed this example earlier. And this would still be the vertex. Okay, it's that key point where direction shifts. Here it's going downwards, slowly settles, and then all of a sudden starts going upwards. This is the vertex. And the vertex is always found on the line of symmetry. In this case, coordinates of negative 1, 3. But because it's the bottommost part of the graph, this is the lowest that this graph is ever going to go. We're never going to go lower than this point. This is what we call the minimum of the graph, or the minimum vertex. Alright, so let's jot some of this down. Go ahead and copy these down as examples. So let's take a look here. Here's our upward facing graph. And so we've learned about two key things here. One, that where I would fold this in half, where things would match up, is what we call the line of symmetry. Go ahead and make sure we copy this down. Line of symmetry, sorry. S-Y-M-M-E-T-R-Y. A little sloppy, hard to write on this computer monitor. And along the line of symmetry, there's a point right here, which is where everything changes. Instead of it coming downwards, it's all of a sudden where it shifts directions and starts going upwards. This is what we call the vertex, V-E-R-T-E-X. And in this case, for this graph, this upward facing graph, it is a minimum because it's the lowest point that this graph is ever going to go. It's the minimum for the entire graph. Oops. M-I-N-I-M-U, minimum. Okay. So that's one possible example. Hopefully you can copy this down better than I'm writing. Now let's look at the other situation. The other situation is our parabola opens downwards, an upside down U shape. Well, the line of symmetry is still the same thing as where you would fold this in half. So in this case, the line of symmetry is here. And then the vertex would be this point right here. But for this vertex, we call it a maximum, M-A-X-I-M-U-M, because if you look at the graph, it's the highest this graph will ever get. We're never going to go above this spot ever again on this graph. It's going to go up, stop here, and go back down. Now, if they ask you, which they might on this assignment, they also will ask you to actually list this information mathematically. So let's go back to our first example. Here, the line of symmetry is right here at x equals, if we look at the x-axis, 1. So we'd say my line of symmetry is at x equals 1. For this one over here, if we look at this line of symmetry, it crosses the x-axis at -2. So it's x equals -2. Okay, so if it's just a graph and they ask you to draw the line of symmetry, then typically we just put a dotted line at the line of symmetry. If they actually ask for what the line of symmetry is, then you just tell them where it's located. Here, our line of symmetry is x equals 1. Here, our line of symmetry is x equals -2. Finally, as far as the vertex goes, well, obviously the vertex is just a point in space. So if they were to ask you specifically for what the vertex is, we'd say this vertex is a minimum, and its coordinates, in this case, are 1, 2. If we were looking down here where our vertex is a maximum, our vertex here would be, let's see, -2, +1. Okay, so now we know how to locate the line of symmetry and how to locate the vertex, how to list it numerically, and how to tell whether that vertex is a minimum or a maximum.